Hello there, this is for Year 12 A-Level Maths. We're looking at exercise 18C. Now this is an extension of what we've seen for the binomial hypothesis test. Sometimes they ask us for the probability, work out the probability that this is happening, and we use that probability to decide whether to reject or not reject H0. Sometimes, however, we are asked at what point we would reject H0, and these are called critical regions or critical values. So we'll look at a few of these here today. It is believed that the ball number 3 comes out of a particular lotto machine too often. In order to test the machine with 44 balls for bias, the adjudicator trials it 50 times. Okay, so we're already starting here to get an idea of what this is about. This is, on the face of it, a binomial test because it either comes out to be this number 3 or it doesn't. I'm doing it 50 times. It says there's 44 balls. The probability of getting it out on 50 different occasions, presumably I put the ball back in each time, is a 44th. And in this trial, the ball actually came out 3 times. Test at the 10% significance level whether the lotto machine produces too many number 3s. Okay, so I suppose the assumption is H0, that P is equal to a 44th. Whereas H1, the alternative hypothesis, this is called the null hypothesis, H1 is the alternative, is that P is producing too many, it's greater than a 44th. And I suppose where X is the number, number of 3s from the machine, something like that. So you're just trying to get all the easy mark at the start of a question. We write down the distribution, we write down the hypotheses, you explain what X is. And then what I want you to do is to think of this number line. You could get anything from 0 to 50. What would you expect to get? Mu equals NP. Mu equals 50 times a 44th. It does sound very much like 1 point something or other. Really, it's just 50 divided by 44. And as a decimal, which is what I want, it's 1.14. I expect to get 1.14 of them. So that's what 1.14 is. I expect to get hardly any. But actually, it says it, I've got 3 of them. So on the face of it, I've got too many. But of course, that could have been just by chance alone. And the way we work it out is we calculate this probability of the tail. This is the probability that X is greater than or equal. Notice it's always this tail, it's not ever an equals, it's a greater than or equals to 3. And I do that by doing 1 minus the probability that X is less than or equal to 2. I want you to get good at that. So on my calculator, I go to Binomial CD. I do that menu 7, I press down. Binomial CD is now number 1. I always choose variable. And what is X? X was 2, N was 50, and P was a 44th. And now my probability is 1 minus 0.895, which of course is 0.105. Now this is, yes, it did say test at the 10% level. So that is greater than 10%. Whenever it is greater, you do not reject H0. And I also need that wordy bit as well. The wordy bit here would be insufficient. Whenever you reject H0, you say sufficient. But here we're saying do not reject H0. So there's insufficient evidence. This is an important phrase. It implies you know it's not a precise science, this. There's insufficient evidence that the machine usually just produces too many number 3s. You just rewrite that. The machine produces. Now, it may well produce too many, but not on the basis of our evidence. There are too many 3s. So that's what I've got. That's something interesting. There I made a note to myself that it was a one-tail test. If it's a two-tailed test, of course, it changes my significance level, but here it didn't. Do not reject H0, insufficient evidence. And this is a better way of writing it, to actually state at the 10% significance level. I forgot to write that. Okay, so next question. A spinner is to be tested for the number of threes it produces. Say it's threes again. I don't know what's so special about threes all of a sudden. It is spun 25 times. Find the critical region. Okay, well, we haven't mentioned this critical region yet, other than me in my introduction. So I want you to, this is the main purpose of the lesson. If I just did the H0, I'm going to write it. Sometimes they don't care for this, but on the critical regions question, because it's a critical region question as opposed to I want you to do a test question. But anyway, so my assumption is that presumably these are meant to be equally likely, so P equals a quarter. H1 would be that P, well, it doesn't say which way it's spun, so I'm going to say it's not equal to a quarter. And essentially, on my, well, presumably X is binomial, I'm doing it 25 times, calling it a quarter. I'd expect to get anywhere from 0 to 25 goes. How many would I actually expect to get? Well, I reckon about there, a quarter of them. Now, to find what this value, mu, is MP, which is effectively 25 times a quarter, which is 6.25. I expect to get 6.25 of them. At what point, though, if I've got too few, would I reject H0? At what point would I reject H0 if I've got too many? And this is what we are doing. So, unfortunately, there's no real obvious way of doing this other than a bit of trial and error. I know it's roughly 6, so now just bear in mind, this is a two-tail test. I think it's two-tailed anyway. It doesn't say that we're getting too many or too few. So because it's two-tail and it's 5% here, that means I get 2.5% each end. And what I need to do is a bit of trial and error. And for instance, on the lower end, probably X is, I'm going to pick a number, I'm going to say 2. I don't know if 2 is right or 2 is small or too big. Is that more or less than 2.5%? So I'm just going to do it on my calculator now. When it's 2 and N is 25 and P is 0.25, it comes up on my calculator as not, I'm quite close there, 0.0321. Now this is too big. This is higher than 2.5%. So this is more than 2.5%. So that basically means I've got to go smaller. I've got to go further away until I get underneath, and that's what I'm after. So X is less than or equal to 1. So exactly the same thing. This time we've got 1, 25 and 0.25. And this time I get 0.00702. Now this is less than 2.5%. And therefore, this is the magic number. This is for my critical region. But that's because this now I know is 1. That's when my critical region goes too small. I still need my higher than 1 number as well. Now that's about 5 away. So I'm going to look at let's look at 11. So I want the probability of X is greater than or equal to 11. I'm not sure if that's right or wrong. But obviously I have to do that by 1 minus the probability X is less than or equal to 10. I'm going to type that in. So my X number now is 10. Everything else stays the same. Well, it certainly looks small. 1 minus 0.970. Now that is 0.02030. Yeah, that's right. So this is 3%. This is more than 2.5% again. So I'm going to have to go a bit higher. Probability that X is greater than or equal to 12. I basically go further away because it's too big. I haven't rejected yet. So this is 1 minus the probability that X is less than or equal to 11. And type in 11, press go, and it says 1 minus 0.989. What's that? That's 0.011. But 989.3. So 117. Now this is definitely less than 2.5%. So again, this is the magic number. So my critical region is x is less than or equal to 1 or x is greater than or equal to 12 from here. And what's the probability? It says that the null hypothesis is incorrectly rejected. Well, I suppose this just comes down to the fact that it's understanding that with probability hypothesis tests, sometimes you're going to get the wrong conclusion. This test is basically saying if you get when you do this experiment 25 times, you get a result which is 1 or lower or 12 or higher, then you're going to end up saying that this is so unlikely to happen by chance alone that the fact that it has happened implies that probably something's amiss. Perhaps it is the dodgy spinner, and that's really what you're saying. You're saying it seems that there's sufficient evidence that the spinner isn't doing what it's meant to do. Now, it could be just by pure chance that's what's happened. I mean, I could spin this spinner 100 times, every time it comes at 4. It doesn't necessarily mean it's a dodgy spinner. Sometimes, eventually, it will spin round 100 times on the trot and land in the number 4. So the temptation would have been, I suppose, to have concluded therefore that we had, for instance, the 5% significance level. I suppose the temptation would be to conclude that you're likely to get this wrong 5% of the time. But in actual fact, because of the nature of the binomial distribution, we were rejecting the premise that this was a fair spinner when it was less than 1. Now we got a probability of that of 0.00702, and also we reject it if it's greater than 12, and that was 0.0117. So in total, we can add these probabilities together. I get 0.0187, and that strikes me as the probability then that we're going to get our sums wrong. Well, actually, I've just spotted that this sum here was wrong. This was 107. Well, that changes things just a little bit. I get 177 now. Let's go to the answer. At least I got the right. Oh yeah, and good job I checked that. It was 177, 0.0177. So the last question, and I've got a question here which is all about the proportion of students who are getting A's in their exam, and it says I've got 120 of them. I get a new textbook, and I want to see if the performance of the students has improved. Oh, that's important. That's improved. So X is binomial. I'm doing 120 of them. The chance of success is 0.33 according to the old scheme, and I think this is a one-tail test, so it's not a two-tail. So that's 120. I would expect to get mu equals MP, which is obviously 120 times by 0.33. I just did this on my calculator. I got 39.6. But because I only want a one-tail test, don't have it there. I'm expecting a number on this side of it, and it's at what point would I think, that's big enough? So again, there's no real way of doing this other than a bit of trial and error. So pick a number. I'm going to say 45. I don't know if that's right, but I've just got to be careful. It's 1 minus the probability x is less than or equal to 44 if I say 45. I think I might have to do a few of these, but I'll type in 44 into my calculator. N was 120. P is 0.33. What's it give me? That gives me, it's not big enough, I don't think, because this is 1 minus 0.829, which is, of course, well, there again, 0.171. So I'm going to play around with a few numbers and come back to you. So I'll pause the video now. So this is what I got. I put loads of sums down. With 50, I found it was less than 5%, but I wasn't sure if it was the first one, so I tried 49, and that was also less than 5%. Wasn't sure if it was the first one. This one with them 48 was actually more than 5%. So this actually here is my answer, and I think it's the probability. The critical region is x is greater than or equal to 49. I haven't quite got time to finish off. I'll chat about this next lesson. I've just got this part B to do. You can see my answer there. But we'll look at exercise 18C, page 406 in the textbook. Thank you.